So guys, this is our iMackey. As you can see, we have done it. This is the entire mechanism for our iMackey. These are the 3D model fingers that we have included in our CAD design. This is the wire winder. This is the wire winder. You can see. This is the ball attached to the line. This is the trigger safety latch. As you can see, the trigger safety notch as well.
Now we must show how the entire thing works. So let's see the working of the trigger and the mechanism.
This is the iMackey thingy. This is the mechanism on which it works. And this is the trigger. The wires are this long because we need the length, and the minimum distance has to be 2 meters from the entire thing. Now if you see this clearly, if I set this back and when I do this, the battery enables it. Works. So
We have to now cock it.
So if I remove the trigger safety is off now, and when I do this, we have engaged the trigger now. It's armed. It's in armed state. Now, do you see it? How the entire thing works? It will be like this. It will be like this. The ball that is attached to the spring will be put inside, and when I will just flick my switch, the entire thing will fire. This is how simple our iMackey is, and this is how it works. So we just saw the mechanism on which this device works. Now we must see the safety that we have installed in this device so that it is regarded safe and we adhere to the iMackey project specifications. It says that we are supposed to build a safety that is supposed to arm it that is supposed to secure it when it is armed, basically when it is in the cocked position or in the armed, when the trigger is armed. So if I arm the trigger using something that I have of my own, so if I cock the trigger, so you can see the trigger is cocked. Now with a light force or with some mistake, this trigger can get misfired. So obviously this device needs to be safe. So I built this second notch, this secondary notch. You can see, instead of putting it in this notch, I can put it in this notch, and these notches are for variable power, so that it can shoot at many distances. Rather than just shooting at one distance, it should be able to shoot at many distances. So that is that. And instead of putting it on this notch, if you put it on this notch, it will get locked and you won't be able to fire it that easily as it is to fire when it is on this notch. So if I just apply some force and don't let it go, so you can see I'm locking it in this notch, the downward notch. Now it will take a hell lot of force more to take it out than to push it down. Like you have to pull it up right now. Even if by mistake it gets triggered, I built this secondary safety that goes in this hole basically and secures it like this. So even if by mistake this goes up, the entire thing won't fire. It will just get stopped, as you can see. Plus when it's over here, it doesn't matter if this thing can hit this or not, because it is just not in contact with the trigger. So this is how the device safety works. Lastly, this is the base on which this entire thing will elevate. So this is the elevation matrix. As you can see, 33 is our calculated degree on which it is supposed to work at the testing arena in the 3D printing lab. That's that, and this entire thing gets installed inside this like this. Then we have this wooden rod to elevate it at our desired angle, and just insert the rod like this. Simple. You can see the entire thing is intact. This is the elevation matrix. It can fire maximum at this angle. It can go higher if we build it to go higher, but our budget doesn't allow it, so we will not go higher than that. So this is the iMackey. Thank you. So now is the time to take our iMackey finger to the arena and test the newly built device. Hardware